3-7, absolute value equations and inequalities. So our objective for this section is to solve equations and inequalities involving some sort of absolute value. And our essential understanding is that you can solve an absolute value equation and inequalities by first isolating the absolute value expression, if necessary, then writing an equivalent pair of linear equations or inequalities. So what we're going to do here is we're going to realize sort of what happens with absolute value equations. So first, I have to isolate the absolute value part of the absolute value equation. Okay, so I'm going to start by subtracting 2 from both sides. So now I have the absolute value of x is equal to 7. So if you remember what absolute value means, it means distance from 0, right? And it means that whatever inside the absolute value, what we're going to do with it is we're going to make it positive. So that means whatever happens to be in here, the absolute value of that number is going to be 7. Well, there are two things that could give you an absolute value of 7. The first is 7, and also -7. So the technique that we're going to use for this is that whenever we have an absolute value expression, we are going to remove the absolute value signs by splitting it into two separate expressions. One that takes care of the positive value that could go inside the absolute value, and one that does the negative value. Okay? And then if I was going to graph this equation, I would simply do -7 over here, +7 over there. I'm not going to worry about the counting out the little tick marks, and I would just put a dot on each one because there are only two expressions. Okay? So our got it problem, same idea. We are going to add 5 to both sides in order to isolate the absolute value. Once the absolute value is by itself, we have my expression, and I remove the absolute value signs by splitting it into two separate expressions, one with a positive, one with a negative. And then it would simply be 3, 2, 1, 0, 1, 2, 3, and I would have my graph as such. Some equations, such as the absolute value of 2x minus 5 is equal to 13, have variable expressions within absolute value symbols. The equation, absolute value 2x minus 5 is equal to 13, means that the distance on a number line from 2x minus 5 is 0 to 0 is 13 units. There are 2 points that are 13 units from 0, 13 and -13. Right? So this is the same thing. So we're going to solve this equation for the first point and the second point. Same basic idea with this. This is a little bit easier to see, this first problem, because clearly there's only two numbers that have an absolute value of 7. But the same thing here is there are two different numbers who, if you plug them into 2x, right, if we have the absolute value of 2x minus 5 is equal to 13, there are two different numbers that if I plug into this expression right here will give me the absolute value equal to 13. It could be the inside could be equal to a positive 13, or the inside could be equal to a negative 13 as well. And then once you put it into the absolute value, both of those expressions are going to give you 13. So let's solve a problem that uses this. Oh, sorry, first let's look at the rule for this. So to solve an equation in the form of the absolute value of a is equal to b, where a represents a value expression and b is greater than 0. That's important, of course, because this number right here can never be less than 0. We solve two separate equations. A is equal to b and a is equal to negative b. So let's look at our first problem. Starting from 100 feet away, your friend skates towards you and then passes you. She skates at a constant speed of 20 feet per second. Her distance t from you in feet after t seconds is given by d is equal to the absolute value of 100 minus 20t. At what times is she 40 feet away? So, with my equation, that distance, which is going to be 40, so 40 is equal to the absolute value of 100 minus 20t. Okay? So this, and let's move the 40 to the other side. Okay? This will come in, this will be important later when we do inequalities, right? You always want the absolute value on the left-hand side. So this can separate into two separate equations. We could say that 100 minus 20t is going to be equal to 40. And 100 minus 20t is going to be equal to negative 40. Both of those answers, whatever they happen to be, when I plug them back into my absolute value equation, are going to give me a positive 40 after I take the absolute value. So let's solve both of these. Let's start, subtract 100 from both sides. We have negative 20t. Welcome to the Alexa Prize. Is equal to, excuse me. Sorry about that. Negative 20t is equal to negative 60. Welcome to the Alexa Prize, a university competition. Divided by negative 20. I'll get you the 2017 second. And t is equal to positive 3. Don't know what was setting off my echo, but I unplugged it, so it should be okay. All right, other one. Subtract 100 from both sides. We get negative 20t is equal to negative 140. Divide both sides by negative 20. And t here is going to be equal to a positive 7. So the answer is, in 3 seconds and 7 seconds, the skater will be 40 feet away from me. Okay? Another friend's distance from you in feet after t seconds is given by d is equal to 80 minus 5t. What does the 80 in the equation represent? What does the 5 in the equation represent? And when is she 60 feet away from you? So what's kind of going on with this particular type of problem is that 80 represents your friend's starting distance from you, and 5 represents their speed. Okay? So we're going to try to solve this. 80 minus 5t. And I want to know when she is 60 feet away. So we're going to get 80 minus 5t is equal to 60. And 80 minus 5t is equal to negative 60. Subtracting 80 from both sides, negative 5t is equal to negative 20. Divide out the negative 5, and we have that t is equal to 4. Same thing over here. Subtract 80 from both sides, and we get negative 5t is equal to negative 140. Divide out the negative 5, and I get t is equal to 28. So here, for this problem, this person is going to be 60 feet away at 4 seconds and at 28 seconds. Recall that absolute value represents distance from 0 on a number line. Right? We mentioned that before. Distance is always non-negative. So any equation that states that the absolute value of an expression is negative has no solutions. So if I'm solving a problem like this, my first step is, I think you know what's going to happen here, but my first step here is to isolate the absolute value. So the first thing I want to do is I want to subtract 12 from both sides. That gives me 3 times 2z plus 9 is equal to -2. This is multiplication, so I'm not going to distribute. Don't put the 3 inside the absolute value. You're not allowed to do that. So we're going to divide both sides by 3 in order to cancel it out. So now we have the absolute value of 2z plus 9 is going to be equal to -2/3. Now, some people, when solving this, will say, okay, this is an absolute value equation, so it's going to be 2z plus 9 is equal to -2/3. 2z plus 9 is equal to 2/3. Right? If you go too fast and you don't think about it, you can easily make that mistake. However, if we look at my expression, the absolute value is equal to a negative number, which is not possible. So this is no solution. Okay? No solution. Just got to be careful and pay attention when doing these problems, right? Add 5 to both sides. We have 3x minus 6, absolute value, is equal to -2. Can't do it. Okay? You cannot have an absolute value be equal to, once the absolute value is isolated. Before it's isolated, right? If this was maybe -15, this would be okay. Right? Because when we add 15 to both sides, we get a positive number on the right-hand side. So you can't just look at this number right here. We have to isolate the absolute value first and then decide if this has no solution. Okay? And we can write absolute value inequalities as compound inequalities. The graphs below show two absolute inequalities. So the absolute value of n minus 1, the distance from 0, is less than 2. So absolute value n minus 1 represents all numbers with a distance from 1 that is less than 2 units. Right? Because distance from 0, so we subtract 1, blah, blah. Okay? So this means that this is going to be in between, this expression, n minus 1, is going to be in between -2 and +2. Okay? However, if we say greater than, then absolute value of n minus 1 greater than 2 represents all numbers with a distance from 1 that is greater than 2 units. So this first one on the left becomes an and inequality, compound inequality, and this one becomes an or inequality. The left is a conjunction, the right is a disjunction. Okay? And usually when solving these, you can kind of tell because less than is going to be in between, and a greater than is going to be shooting off to both sides. So you can solve an inequality in the form absolute value of a is less than b, where a is a variable expression, b is greater than 0. We're going to solve the compound inequality, -b less than a is less than b. And if we have greater than, we are going to use an or. So you can look at these expressions and sort of tell what's it going to do. Well, this is greater than, which means the expression is going to be going away, right? It's going to be greater, it's going to be going greater in one direction, and it's going to get a bigger negative number in the other direction. So that is a disjunction. That means we are going to have an or inequality. Okay? If you can't remember that, well, let's solve it the first way first. So we can say that 8n is greater than or equal to 24. And look carefully back here. When we have an or expression, our first expression with the positive, my inequality symbol is going to match up. It's going to be greater than. But in the next one, it's going to switch. Okay. So when we solve the next inequality, we're going to say that 8n is less than or equal to -24. So I kind of try to remember this by the rules of negative numbers and inequalities, right? When we divide by a negative, we have to switch the sign. When we make my expression negative, we have to switch the sign as well. So let's solve both of these. Okay, so this is going to be n is greater than or equal to 3. divide both sides by 8 here, and n is less than or equal to negative 3. Let's put a 3 there. 2, 1, 0, 1, 2, 3. Negative 3 right there. We'll put a dot here. And this kind of works out because n is greater than or equal to 3, which means we're going to go to the right. And less than or equal to negative 3 means we're going to go to the left. Okay? And so for my got it problem, I'm going to do the same thing. I'm going to keep this expression the same. So we have 2x plus 4 is greater than or equal to 5. And I'm going to say 2x plus 4, but now I'm going to reverse the inequality sign. Okay? So that's a little handy way to remember, whoops, negative 5, right? I'm going to switch the inequality symbol when I change the sign. A little handy way to remember what my expressions are supposed to look like. Subtract 4 from both sides. 2x is greater than or equal to 1, which means x is greater than or equal to 1/2. It's okay to get fractions, decimals, right? Not going to kill you. And then subtract 4 from both sides. 2x is less than or equal to negative 9. Divide out the 2. And be aware, the rules here still apply that if you are multiplying or dividing by a negative number, you must switch the sign. Here, we're not, but just in case, good to mention. Okay. So let's call this 0. That's 1/2. We're going to put a dot. And 1, 2, 3, 4. Here's 4.5. And, oh, whoops. All right, let's fix this. So let's call this 0. Let's call that one positive 1/2. And this is, of course, negative 4.5. So 1, 2, 3, 4. So we're going to go right here. Negative 4, negative 5. All right, and we're going to go to the left from that one and from the right with that one. All right, so let's solve an absolute value equality involving a less than. So a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects a box to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weight for the box of crackers? Okay, well, so we want to relate the difference between the actual and the ideal weights, and this is at most 5 grams. So that means the absolute value of whatever the weight is minus what it should be has to be less than or equal to 5. Okay? So now I could realize that this is a less than inequality and set it up with a conjunction. So I could go negative 5 is less than or equal to w minus 213 less than or equal to 5. All right, and then add 213 to both sides. Or, sorry, add 213 to all sides. Okay, and we would get 208 is less than or equal to w is less than or equal to 218. Okay. We could do that. All right. Also, we could also try to solve this. If I couldn't remember that it's a conjunction, we could solve this with the same technique that we just used in the previous problem. We could set up the equation with my positive answer, and then when I solve my negative answer, I can reverse the inequality sign. Here, w is less than or equal to 218. And here, w is greater than or equal to 208. So you do get the same answer. What you have to realize here is that the answer is going to be in between these two numbers. Okay, so it is helpful to remember, and you can kind of tell this because the W, if you think of a number line, this one's going this way, this one's going this way, and eventually, if you put them in the right order, that they will eventually cross. Okay, but if you can't remember that the rules for the different inequalities, you can always set it up this way. It is helpful to just set this up as a conjunction like I did first and solve it without having to go all through this thing. Okay? Just be sure not to make the mistake of just adding 213 to each side of the expression. You can't do, you have to separate it into two expressions first. You cannot do any operation that's inside the absolute value. You have to save that until we split it up into two separate equations. Okay? So to review, to solve an inequality, the first one is plus or minus 5. X is equal to 5, x is equal to negative 5. Those are the two things that make that expression equal to the absolute value equal to 5. For number 2, I would add 3 to both sides. For number 3, I would set it up as 2t is equal to 6, and 2t is equal to negative 6. So it would be plus or minus 3. Okay, but you have to separate it first. You can't just divide out the 2. Okay, for number 4, okay, the setup would be a conjunction. So we would go negative 5 is less than h minus 3 is less than 5. And for number 5, I would set it up as x plus 2 is greater than or equal to 1, and x plus 2 is less than or equal to negative 1. How many solutions do you expect to get when you solve an absolute value equation? Usually, you're going to get 2, unless you get 0 somehow, unless you get the answer 0 and they only have one solution. But usually, you're going to get 2 solutions: a positive and a negative. Two numbers that are the same distance away from 0 on the number line. Explain why the absolute value equation 3x plus 8 equals 5 has no solution. Because when you subtract 8 from both sides, you get a negative number, and the absolute values cannot be equal to a negative numbers. Explain the similarities and differences between solving the equation of x minus 1 is equal to less than 2 and greater than 2. So the first one, the similarities are all the same equation, so the method is going to be the same. We're going to solve the positive equation and the negative equation. In the first one, it's nice and simple, equal to. In the second one, we're going to solve x minus 1 is less than or equal to 2. And we're going to set up the conjunction like this. And for the next one, we're going to set up x minus 1 is greater than or equal to 2. X minus 1 is less than or equal to negative 2. Okay. And that is 3-7 absolute value equations and inequalities.